Hi class, this is my first pre-recorded lesson. I'm recording it a little early so that I can upload it around the time that you expect to find me online. I'm finding that the upload times are way too long for the live feed, so it's better just to do it this way. Just check in anyway, write your names in the comments, and you can ask any questions if you like, and I'll get back to you within a reasonable time. I'm going to try giving you a test today. Okay, I'm going to give you 3 questions, and I'll post it at the end. For homework, I had given you 1659 and 1675. So on 1659, it says the acid dissociation constant for benzoic acid is 6.3 times 10 to the negative 5. Calculate the concentrations of hydronium, benzoate, and benzoic acid in the solution if the initial concentration of benzoic acid is 0.05 molar. So rather than drawing the whole molecule out, I'm going to call it HBE for benzoic acid. So this is the ionizable proton. It's going to dissociate into H plus ions and the benzoate anion. We're told the original concentration is 0.050. No, sorry, 59. This is a nice table. Just double checking I copied it right. And we find out that Ka is equal to 6.3 times 10 to the negative 5. So everything we need is up there. So we set it up by saying that initially there's nothing in solution, but after some benzoic acid dissociates, a certain amount X disappears, and a certain amount X of protons appears, or hydronium ions if you like, because it's in an aqueous solution. I just left out the water part. Benzoic concentration increases by X, so at equilibrium you have 0.05 minus X, this is at X, and this is at X. So since Ka is equal to the concentration of H plus, or hydronium as you wish, okay, and that equals 6.3 times 10 to the minus 5, and the two variables X and 0.05 minus X are set up. All that equals 6.3 times 10 to the negative 5. So we're going to multiply 6.3 times 10 to the negative 5 by 0.05 minus X, and it's all equal to X squared. Now, because the amount of dissociation is going to be very low, I'll show you 2 ways. I'll show it to you the Ark Approximation Method, and with the Quadratic Formula we should get fairly close answers. Because X is way less than 0.05, we could probably approximate this down to 0.05. So what you end up getting is 6.3 times 10 to the minus 5 times 0.05 equals X squared. So that solves down to this. square root of that. No. Okay, there we go. So what you get is 1.7748 2393 times 10 to the negative 3 as x, which is equal to the hydronium ion concentration. So if you take the pH equals negative log of the H3O concentration, and you get pH of 2.75. Okay, that's with the approximation. But let's see what we get if we don't use the approximation. So I'll just erase the part where we did the approximation and continue it without. Let's copy that for 30 seconds. All the conditions are identical. You know, everything is the same up to that point, but then what you do is you just leave that and you actually distribute the number into the bracket and see what you get. So you're going to say 6.35 times 0.05. Gives you 3.175 times 10 to the negative 6 minus 6.3 times 10 to the negative 5 x equals x squared. Set it up as a trinomial. I'm just going to write the answer here, 2.75, so I don't forget. So our trinomial comes out to x squared plus 6.3 times 10 to the minus 5x minus 3.175 times 10 to the negative 6. All of that equals 0. Plug that into your calculator's quadratic function. So you press mode. You press equation, so that's number 4. Then you press quadratic, which is number 2, and then you enter the values. So the first value is 1. Enter. The second value is 6.3 exponent negative 5. Enter that. And the third value is negative. Don't forget the negative or else you get a wrong answer. It's 3.175 exponent negative 6. Enter that. And you get a syntax error because I wasn't looking at what I was doing, but you get the picture. Let me do that again. Oh, I just didn't enter the last number. So it's negative 3.175 exponent negative 6. Enter. All right, so you get two values, and the positive one is the one you keep. So you get x1 and x2. 1.75, 0.631. 38 times 10 to the negative 3, and you get negative 1.8136313 times 10 to the negative 3. This is the one you keep. This one you discard because you can't get a negative concentration. So then let's find out what that pH is from the basis of this equals x, which is the H3O plus concentration. So pH equals negative log of H3O plus concentration, and you get back to normal mode, log 1.75063 exponent -3 gives you a pH of 2.756, which rounds up to 2.76. So your approximation method gave you a pretty good estimate. You wouldn't get marked wrong for that, unless of course I had asked you to actually use the quadratic formula to solve it exactly. But you see that the approximation for most weak acids, you get a very good answer. 59. Continued. Is there anything else? No. Okay, let's go to the next one. 75. 75. It says calculate the molar concentration of hydroxide ions in a 0.075 molar solution of ethylamine with a Kb of 6.4 times 10 to the minus 4. Calculate the pH of this solution. Just got to be careful that you answer the question they're asking for. This is a base, so your pH is going to be above 7. Okay, let me just copy the results so that you have to copy. So ethylamine is CH3, CH2, NH2. If you put it in water, it'll pull protons off water, and then you get ethylammonium and some hydroxide. They say that the concentration initial concentration is 0.075. A certain amount X dissociates, so you get 0.075 minus X. This is not important because that's solvent, right? So it stays essentially the same. Kb is 6.4 times 10 to the minus 4. This will be initially 0, then increases by X, becomes X. Then you start this at 0, increases by X, and turns up at X. All this is going to be equal to the concentration of ethylammonium CH3, CH2, not 3, CH2, NH3 plus times hydroxide ion concentration over concentration of the initial ethylamine. So this is represented by X times X over 0.075 minus X. Again, let's do it the first time by approximation, second time by quadratic formula. Let's see what kind of results we get. So if we pretend this number is very small, actually we don't have to pretend because it is. So 0.075 minus X can be rounded down to this. So you'll get 6.4 times 10 to the minus 4 equals X squared over 0.075. That's a reasonable approximation. This X hardly puts a dent in the 0.075. So let's just run it that way and see what we get. 6.4 exponent -4 times 0.075 gives you 4.8 times 10 to the -5, and that equals X squared. So X is the square root of that, so we get X, which equals the hydroxide concentration, equals 6.928 to 0.323 times 10 to the -3. That means the pOH is equal to the log of that, negative log of that. What you get is 2.1593, which rounds down to 2.16. Excuse me. I don't think this is a cold, this is allergies. Because I get a tickle. It's been ongoing now for a month. It's Mama's fault. But don't tell my wife. So it's 2.16. That's the pOH. So because they're asking for the pH, so we can do a little. So pH plus pOH equals 14. pH is pOH is 2.16, so 14 minus 2.16 is going to give you the pH. I just left the number in my calculator, so what you get is pH equals 11.84. Okay, let's write that up here. pH equals 11.84. Now, that was with the approximation method. Now let's do it with the unrounded equation and full calculation. So if you have 6.4 times 10 to the negative 4 times 0.075 minus x is equal to x squared, and you're going to get 6.4 exponent negative 4 times 0.075 gives you this 4.8 times 10 to the negative 5. You know what I'm going to do this time? I'm going to actually show you what it looks like when you use the quadratic formula, which is like penance, frankly, but we'll see what that looks like. Minus 6.4 times 10 to the negative 4, x equals x squared. So your trinomial looks like this. You're going to have x squared plus 6.4 times 10 to the negative 4x minus 4.8 times 10 to the negative 5, all that equals 0. So we're going to plug that into the quadratic formula. Give myself maximum room up here. Oh, I erased the answer from the last time, so let's put it at the bottom, 11.94. Should get the same answer. Very close to it. Not erase our trinomial. That's what we need to work with. So the quadratic formula is x equal negative b plus or minus the square root of b squared minus 4ac all over 2a, where a is 1. So let's put it all numbers. So negative of 6.4 times 10 to the negative 4 plus or minus the square root of 6.4 times 10 to the negative 4 squared minus 4 times a, which is 1, c, and c is this, negative 4.8, oh no, was that a 5? Yes, it's still my calculator. Woo. Okay, negative 4.8 times 10 to the negative 5 all over 2a, which is 1. Okay, so you get negative 6.4 times 10 to the negative 4 plus or minus the contents of this bracket. So just multiply that by that part by 4. Becomes positive 2. I should say positive as well. So what you get inside that bracket is 6.4 times 10 to the negative 4 all squared plus 4 point, how many zeros? 4 zeros. 1, 2, 3, 4, 4, 8. Uh-oh. 4 times 4.8 exponent negative 5. Okay, I'm starting to not trust my calculator. I must be pushing the wrong buttons. Okay, so then still do the contents of that radical sign. Let's square that. So 6.4 exponent negative 4 all squared open bracket 6.4 exponent negative 4 all squared gives you that. All right, so you get 4.096 times 10 to the minus 7 plus 1.92 exponent negative 4 gives you that. So you take the square root of that and you get this. Okay, so negative 6.4 times 10 to the negative 4 plus or minus 1.387 11788 times 10 to the negative 2 all over 2. Now you're not going to get, the negative value is useless, so we're not going to go there. I'm just going to say minus this plus that, so it's going to be basically subtracting this from, so minus 6.4 exponent negative 4 and divide that by 2. So x1 in this case is 6.615589 times 10 to the negative 3. X2 is negative, so we're just going to discard it. That's the right one. So now let's take the pH of that, the POH, sorry, by taking the log of it. Log of that gives you a pH of 2.179. So POH equals negative log of the OH minus concentration. What you get is 2.17943. If you want a pH, you add 14 that, because remember 14 minus the POH is going to give you the pH. And what we'll get is 11.82. Okay, so it's a small difference. Let's double check it by doing it on the actual calculator function. But you see how laborious this is. That's why it's a good idea to get yourself a scientific calculator and just get used to using it. You can save a ton of time. If you're doing this on the final exam, because you didn't have a calculator, you're going to be pulling your hair out. So enter mode for quadratic. The first number is 1, second number is 6.4 exponent negative 4, third number is negative 4.8 exponent negative 5, enter, and you get 6.61558938. So you see, get the exact same number, and that corroborates that. That's the correct answer. So when you use a quadratic formula, you get this answer. When you use your approximation, you get 11.94. It's a very small difference, not completely negligible. And you know, if you're looking for an exact mathematical answer, it's better to use the quadratic formula. Now, here is your test. I'm going to give you 3 questions, and I'd like you to send it to my email. You know how our email goes at school? It goes first name, last name, at, you know what school we go to. It's the acronym with the 5 letters, and that it ends in .org. I'm not going to tell you the full email because there are all kinds of weirdos out there lurking, trying to do stuff. All right, here are your questions. So, test. $16.60 1676, and well, that's a good one. 1617. 16117. Okay, so here they are. Obviously, you should show your work. Okay, and I will, and also check into class by writing your name on the comments, and then yeah, we'll see you tomorrow. Bye bye.